Hello and welcome back to Code Snippets. We're going to be talking about loops now. So, what is a loop? Well, if we figure that our program is just a timeline from A to B. So if we start here, then we run code, we keep going, all in a straight line down to B. And once we get to B, our program is done and it terminates. Well, what a loop does is somewhere between A and B in this path here, we have a circle like this that sort of branches out from the rest of the code. So this loop, just like that, will go in circles n number of times. So depending on, whatever conditions we put into this code, that determines how many times this loop will go around. So if we start here, we go down, we keep going, and then we get here, and let's say we loop 10 times, we go 10 times around, and then we finish and go down to B. And that would be the end of our code execution. So how do we write loops in Java? Well, first, there's two different main kind of loops. You have a for loop and a while loop. Now, what's the difference? A for loop is when you know how many times to loop. So, for example, I know I want to loop this 10 times. Then you would use a for loop. A while loop is for when you don't know how many times to loop. So, for example, I want to loop until this is no longer true, or I want to loop until I get to some sort of value, or until this thing happens. That's when you would use a while loop. So essentially, you just mainly ask yourself, do I know how many times I want to loop? And if the answer is yes, you're going to use a for loop, or else you're going to use a while loop. So you don't really have to ask yourself that second question. So let's try some examples. Well, the easiest way to make a for loop in Java is to type for and hit Control space, and that'll bring up this menu here. And we're just going to, as you can see, it says iterate over an array. We haven't gone over what arrays are, and if we click through these, it shows you some different kind of for loops you can make. We're just going to click the first one and modify this. So let's just loop 10 times. So this is the basic structure of a for loop. You have for, then inside these parentheses, we have int I equals 0, and then a semicolon, and then I is less than 10, semicolon, I plus plus. Okay, so you should have seen all of these statements before if you've watched all my videos thus far. Here we're declaring an int type variable called I, and we're initializing it as 0. Here, we're saying I is less than 10. So as long as I is less than 10, we're going to keep looping. That's what this means. So this is a Boolean expression. And then here, I plus plus, that again means increment, which just makes I go up by 1. So this line will only get run once when we very first start the for loop. So I only gets declared once, and then once the for loop ends, I no longer exists. Then we have I is less than 10. This gets run every single loop. At the beginning of the loop, it checks whether or not I is less than 10. If I is less than 10, then the loop is good to go, and it'll keep going. And then I plus plus happens at the end of every loop. So once we get down to this bracket, I goes up by 1, and then it goes back up to the top to check, is that number still less than 10? So, in this case, we're going to enter 10 different numbers, and Java is going to print out the number that we entered that is the highest. So we need to keep track of that number. So int highest num, and we're going to set that highest num equal to integer.min value. Okay, so what did I just do here? What does that mean? And why did I do it? Well, we need to initialize highest num with a value. And that's because if we sys out highest num down here, and if we don't initialize it, if we just say int highest num, like that, we get an error here saying, hey, your variable wasn't initialized. And even if we say something like, oh, well, then I'll just say that highest num is equal to 10. We still get that error. And that deals with scoping and how variables are viewed within the Java program. So I'm not going to go into scope now, but just recognize that we need to actually initialize this value. So we also want to make it a value that no matter what number the user types in, that number will be higher than whatever we initialized it. Because let's say we initialize this as 0. If the user enters a bunch of negative numbers, none of those numbers are greater than 0, so we'll print out 0, but we never entered 0, and 0 isn't the highest number of anything that we entered. So by entering, or by initializing it as integer.minValue, we're guaranteeing that no matter what the user enters, it has to be greater than or equal to the minimum value that an integer can store. So that's what this is. Based on the memory that an int type variable takes up, the integer.minValue is actually the minimum value an integer can store. So if we print this out, it's a very large negative number. 2147483648, blah, blah, blah. So this corresponds to negative 2 to the 31, I want to say. And again, that's just based on, because it's a 32-bit number. So negative 2, negative 2 to the, oh boy, way to make it a scientific. There we go. Negative 2 to the 31. And there's the exact number that we just got printed out. Now you also might be wondering, well, if it's a 32-bit number, why did we raise it to the negative, or to the 31 instead of 32? And that's because we have a single bit out of that 32-bit chain. Remember, a bit is either a 0 or a 1. I don't think I've mentioned that before, but that's the essence of binary. So a binary string is just a string of zeros and ones. You may have heard something on your computer like a gigabyte or a kilobyte or a megabyte. So what is a byte? A byte is just a string of 8 zeros and ones. It's a binary string. A bit is just a single 0 or 1. So a bit is the smallest amount of memory that a computer can store. So if here we have 32 bits, 31 of them are dedicated to the number, and the 32nd bit is dedicated to whether or not it's positive or negative. So that's why we raise it to the 31 and not the 32. So this is the smallest value that an int can store. And of course the highest one would be the positive version of this. Okay, so now how do we get the highest number? Well, we're getting some user input, so that means we need a scanner, because scanner is the only way that we can get user input. Just like that. And now we have our scanner, so we can use it in here. So we're going to say if highest num is less than input.nextInt, then that means, actually, we should probably store, we're going to say int user in equals input.nextInt. Okay, now we can do our check, because we actually want to reference this number twice. And if you say input.nextInt once and then call it again, you're actually getting input from the user twice. So we don't want to do that. We just want to store that number once and then be able to reference that number as many times as we want. So int user in equals input.nextInt. Then we can say if user in is greater than the highest num, then highest num is equal to user in. We want to take that value that they just typed in and assign it as the new highest number. So that's what's happening here. And then of course it loops 10 times. So if we print this out, or if we run this, and of course, we never ask the user or told the user what we're doing. So we should probably do that first. So before we get the answer, we need to ask the question. So we'll put that right here. We'll say sysout, enter 10 numbers, just like that. So we're going to hit run. Now it says enter 10 numbers. Okay, now as the user, I know what to do. So I'm going to enter that, this, and that. We're going to keep going. And I think one more. Okay. So we entered 10 numbers, and the spacing and hitting enter, none of that matters, because we're just using input.nextInt 10 times in a row. And then it grabs this 5345. That was the highest number that we entered out of those 10 numbers, and that's the one that it prints out here. Because every time that the number we entered was greater than the number it stored, it took that number and then reassigned it to the number that it's storing in order to save that max value. Then it takes that and prints it out to highest num. Now let's say we just wanted 5 numbers instead of 10. Well, then we'd have to change this 10 to a 5, but we'd also have to change that 10 to a 5 here. And what if we had 30 more references to the number 10? Then we'd have to change all of them. And this is called hard coding. We want to avoid this. So we're actually going to store this as a variable. So int num equals 5. Then anywhere we have 5, we can replace that with num. We can say plus num, like that. And then put num here. So now it's only going to ask for 5 numbers. Just like that. And of course 79 is the highest of those. And now we can change this 5 to a 3, rerun it, and now it says enter 3 numbers, and we're only going to enter 3, and 25 was the highest. So instead of changing both these numbers, changing it here and changing it here, we can just change it here and save ourselves some time and energy. Okay, so this is the essence of a for loop. It just runs this code a bunch of times in a row. And to better illustrate that, I'm going to comment this out. And I'm going to comment this out as well. And we're just going to print out I. Just like this. So if we run this, it prints 0, 1, 2. So it ran 3 times, right? Printing out each one of these numbers. And it printed out, because I starts as 0, so we run this, prints out I, well I is equal to 0, and then we reach the end of our for loop. So now I goes up by 1, and 1 is still less than 3, so we're good. So we print out the number 1, then it goes up by 1, now I is 2, 2 is less than 3, so it prints out 2, and then it goes up by 1 again, but now 3 is not less than 3, so now the for loop stops, and we can illustrate that with a done, just like that, even though it's a little self-explanatory because our program is no longer running. So now let's change this number to 20, and let's run it again. Well, now it printed out the numbers 0 through 19. So our code still ran 20 times, but instead of 1 through 20, it's 0 through 19, and then it prints out the done because we are out of our for loop. So that's all a for loop does. It just runs the same code a specific number of times. And you can use this I if you want to use that for some variable, but you don't have to. I is just acting merely as a counter. However, it's very important that you don't alter I, because let's say we put I equals I minus 1, just like that. Or you could say I minus equals 1, or I minus minus. All of those will do the exact same thing. here I'm just going to illustrate that I is going down by 1 in the most basic way I can. If I run this, nothing's happening. As you can see, my mouse, the loop is running. There is something that it's trying to do. It's still running. And if you look here, there's a red square that says terminate. And that's because our code hasn't stopped yet. Because if it did, it would print out the word done, but it hasn't printed anything yet. So we're actually going to stop our program, and then we're going to hit this X, which means remove all terminated launches. So it'll get rid of any hidden, or any programs you launched in the past, because you can actually launch multiple ones. So here I launch one, and if I don't hit the red square, I can just launch another, and another, and another, and just keep launching them over and over. And now I have a bunch of programs running in the background that really don't need to be. So you just want to terminate those and then close them out so you can see the ones that are also running in the background. And now all of my programs are gone. So this is why you don't want to modify I unless you really know what you're doing. So just be careful that you don't change the value of whatever counter you're working with here. So let's head over to a while loop. Well, how do we start a while loop? All you have to do is just say while, and then some condition goes inside these parentheses, just like that. So in this case, let's get a variable, int x equals 10. I'm going to say while 10 is greater than 0, or something like that. And we're going to say x, well, first we're going to print out x. And then we're going to say x divided by equals 2, like that. So if we run this, now we've entered an infinite loop. So I'm going to stop that. And that's because 0 divided by 2 is 0, and 0 is not less than 0. So now we run into a problem. So I'm actually going to change this greater than to a greater than or equal to. So if we rerun this, oops, I don't think I saved. Let me try that one more time. Oh, my bad. Not 10, x. Of course it'll loop forever. Okay, let's try this one more time. Okay, great. So we wouldn't have had an infinite loop, but I just entered some silly data. Instead of x greater than 0, we entered 10 is greater than 0, which will always be true. So that's my bad. Okay, so we printed out x, which x started as 10. 10 is greater than 0. So it's going to print out x, which is 10, and then divide 10 by 2. So now we get 5. 5 is greater than 0, so we print out 5, and then divide 5 by 2. So that's 2, because if you divide 5 by 2, that's 2.5, but you're going to ignore the decimal because we're working with ints. So it's just 2. 2 is greater than 0, so we print that out. And then 2 divided by 2 is equal to 1. And then 1 is greater than 0, we print that out. And then 1 divided by 2 is 0.5, or 0.5, but we ignore the decimal, so now we get 0. And of course, 0 is not greater than 0, so our loop stops. And we can express that again with a done. And of course, our loop has ended. And we can do one more printing out of the value for x. And of course, that will be 0, because 1 divided by 2 with integer division is 0. And we can also, because essentially a while loop is just an if statement that keeps going, and it keeps running until that if statement is false. So we can treat this exactly like we did when we worked with the Boolean expressions. We can say x is greater than 0, and x is less than 20. So as long as it's within this range from 0 to 20, it'll run, in which case it is. If we said x is equal to, actually we can call it 20, the loop never runs, right? Because x is equal to 20, 20 is not less than 20. So since one of these conditions is false, that means the whole thing is false. So this loop never runs, so then we just print out 20, and then we say done, and it never looped. So that's the essence of while loops. And of course, if you wanted to make an infinite loop, the way I accidentally did earlier, is you could just say while true. And of course here we get an error because this is unreachable. Because we have an infinite loop, it'll never stop. Or you still could be clever and say if x is equal to 0, then we're going to break. So this is a keyword I haven't talked about yet. So the break, if we hover over it, notice that while is also highlighted. So break means stop looping, no matter what. Just quit what you're doing and end the loop. So if we run this, we get 20, 10, 5, 2, 1, 0, which is exactly what we would have gotten before had we left the x is greater than 0 for true. So we have break, which stops looping, and this also works in a for loop as well. So we can say sys out I, and then if I is greater than 5, then we're going to break. And so if we run this, we get 0, 1, 2, 3, 4, 5, 6, and because 6 is greater than 5, we stopped looping, even though we had to go up by 20. Or, let's say we only wanted to print out the odd numbers. So we don't want to stop looping, we just only want to ignore any time I is odd. So, let's say if I mod 2 is equal to 0, this just means if I divides evenly by 2, that's what this whole statement means, then we're going to continue. So continue, it's similar to break, but instead of just stopping the loop completely, it stops this specific loop, this specific run that we're doing here. So it ignores everything after this, and it just goes back to the top of the loop. So for example, if I is equal to 0, I mod 2 is, or 0 mod 2 is equal to 0, that is true. So we're going to continue. We're going to skip the rest of our loop. So we're going to go down to the end and just shoot back up. So now 0 plus plus, that's 1. So now we're going to go on to the next iteration, as it's called. So every time a loop runs, that's called an iteration. So this, every time I is even, it's going to skip printing it. So if we run this, now it only prints out the odd numbers for I. So break and continue are very, very helpful for loops. They are control statements. That is what they're referred to as. And there's one more control statement that doesn't deal with loops, but I'm not going to get into that until we start talking about methods, which should be soon, but not quite yet. So those are your control statements. Both of them work for both while and for loops. So if we say x mod 2 is equal to 0, then we're going to continue. And then here we're just going to say x plus plus, or actually we'll say minus minus, x minus minus, while x is greater than 0. So if we run this, now we only got the even, well, oh, hold on, let me move this down to here. Okay, so now we only got the odd numbers that printed out, and then we print out 0 at the end here. If we get rid of that, then that's more clear. There we go. So it continued, or it skipped over this line here whenever x was divisible by 2, and then it just goes back up to the top of our while loop, x goes down by 1, and then the process starts over. So that's the general idea of loops. Now there's also for each loop and a do while loop. Those are a little bit more complex. I'm not going to talk about a for each loop, but I will mention exactly what a do while loop is. So I'm going to comment this whole section out. So let's say while x is less than 20, right? We sys out x, and then here we sys out done. to show that our loop has in fact ended. If you run this, the loop never ran because 20 is not greater than 20, or 20 is not less than 20, however you want to read that. But let's say we wanted this code to run at least once. So if we have, instead of while this, we're actually going to replace this whole thing. We're gonna cut it out, and we'll replace it with the word do. And now you can see we get an error here that says, please insert the while expression to complete the do statement. So we're going to paste that right there, and then put a semicolon at the end. So this is the first time, and the only time, that you're going to put a semicolon after a loop. So before, you always use the opening and closing brackets for your loops. Even if we go over to the for loop, you don't put a semicolon here. You put an opening curly bracket, and then a closing one to end the for loop. So you don't want to use semicolons. But here, this is the only time you use a semicolon when defining a loop structure. So if we run this, now it printed out 20, even though 20 is not less than 20. We still printed out X. We still ran this once. So if there's something where you would at the very least, you want to run it once, but then after that, it's sort of up in the air, that's what this is for. This is where your do while comes in. So it's a bit, just a little bit more complex than a regular while loop, but not so complex that you shouldn't be able to pick it up and understand how it works just shortly after learning what a while loop is. So that's your for loop and your while loop and your do while loop. And again, we'll talk about what the for each loop is later on when we get into arrays. So that'll be the next episode. We're going to talk about exactly what an array is and how they're used.